This is horizontal construction for our innovative method. We chose Geopiers. I'm Austin. My team members were Harpst Gibbs and Travis Lightle. For the Jennifer project, we're going to run through the introduction. We're going to go over the current methods of Geopiers, discuss how they're innovative. We'll run over the benefit comparison, case studies, and conclude. What we have here on the right is a picture of standard Geopiers. They're user replacement of H piles. We'll go over other type of current piles later. They're used to increase bearing capacities and decrease settlement of soils. They were invented by Tenzar in 1989. They use patented technology in crushed aggregate. They have many advantages, including cost savings and faster installation methods. The current methods, the main ones used are steel piles, concrete, and wooden. They use provide additional bearing capacity and reduce settlement of construction buildings. Steel beams are driven by hammer, pure steel filled with concrete. For concrete, you have cast in place or precast piles. They're driven if they're precast. For wooden piles, you have pre-treated or treated wood, and they're also driven.
To get into the innovation more of Geopiers, to start off the process, you drill about a 2 to 3 foot hole up to 30 feet deep. You place a bulb in the hole. I'll get into that more in a second. You tamp the bulb, so just put energy into the bulb, crush it, then you layer aggregate and continue to tamp all the way to the top. We'll get into the process a little more in a second. The uses of Geopiers, this is why we believe they're so innovative. They have so many different things that they can do. Foundation support, they're in slope reinforcement, uplift and lateral. They can have an anchor tied to the bottom of them and provide that. They're applicable to many varieties of construction. They're also used in wind turbines and a variety of different foundations. To get into the process of it, first we're going to drill a hole or press a hole into the ground. So in this case, this is a Geopier company out of California. They press a hole into the ground up to 30 feet deep. Load the rock, which is the bulb I mentioned in the last slide. You raise the hammer out and then start crushing it with another hammer, and then you just crush it all the way to the top. Several different layers all the way to the top. For the benefits, we're going to run over steel and concrete first. So for the cost of steel, concrete, and wood, which is our traditional piles that we went over earlier, they're about $9 to $12 per supported kip, so per foundation of the weight that you have on each pile. We're looking at about 9 to 12, as opposed to Geopiers, which is 4 to 8. In some cases, that's half, depending on the specific project. So in your time, we're looking at about 660 to 720 vertical linear feet per day, of course, depending on whether you're using steel, concrete, or wood. As opposed to Geopiers, about 800 to 960 vertical linear feet per day, which is can come up to about 30% savings in time, and construction time is money. For strength, steel, concrete, and wood are all pretty smooth products, so they have low skin friction, and skin friction is the main variable in bearing capacity, as opposed to Geopiers, which is a rough aggregate, has a rough surface, has a high skin friction, which leads to a high bearing capacity. The economics behind steel, concrete, and wood, they don't provide any lead points, and they're all processed materials. They're processed in a factory, as opposed to Geopiers, whereas they do provide lead points, and they're not processed, so they're just straight gravel. So to get into the case studies.
2 examples of case studies that we used was a success and a failure where Geopiers were used. The success was a Lowe's superstore outside of Chicago, Illinois. The site had previously been undeveloped due to unideal soil conditions, and it was too expensive for them to use the area because with conventional pile systems. The Geopiers was used along with a engineered fill on top of them, and it was able to be successfully built on. To play into the production rate of Geopiers, the site installed 5,700 Geopiers in approximately 90 days. The failure where Geopiers were used was an elementary school in Utah. The Geopier system failed because of improper water drainage, and they remained water saturated for too long, and there were severe settlement issues in some places of the building. The floor settled 3 inches. With a better design and site preparation, the failure could have been prevented. To conclude on Geopiers, they're an excellent alternative to piles. It's new and innovative because it is economical. Production rate to install them is much faster. You do get the green benefit from not using new materials, and Geopiers are a registered trademark, and this is the website, geopiers.com.
And that will conclude our presentation on Geopiers.